First question is to find the length of the side opposite to the given angle. So our given angle, like I said, is pi over 8. So they're looking for that side right there. And you're provided with information about that side. So which trig ratio would you use to find this opposite side, which is called x? Christian? Yeah, when you sine, I'll just say sine of pi over 8 is equal to x over 42.5. Multiply both sides by 42.5. And now we have our x side. And should be that 16.26 number. Make sure you're in, what mode do I need to be in now if I'm going to use my calculator? It needs to be in radians. It needs to be in radians because that number right there, that number right there is always going to tell you the number you put. We call that the, if you remember, we mentioned this when we talked about logarithms. Okay, we'd have log and then some number inside there. We called that number the argument. Okay, you're going to hear me call pi over 8 the argument. Okay, so that argument tells you the mode you got to be in. Okay, so if it lacks a degree symbol, then you got to be in radians. The pi is also going to kind of maybe provide you insight that it should be radians. That's not always saying they could put pi degrees. You don't see that a whole lot, but they could. And sometimes even if you have radians, they might not be expressing the pi. So it might be like 1.5 radians. There'd be no pi there. So you just got to pay attention to the unit this is. That tells you your calculator mode. So now I'm going to type in 42.5 sine of pi over 8. And it gives me that 16.26 that they're looking for. Now, in regards to finding it says find the length of side adjacent to the given angle, you got a couple options here. You could say that, we're looking for the adjacent side here. Maybe we call that y. We could go through and say, okay, adjacent, if I have adjacent and now I have hypotenuse, I could use cosine, right? So your cosine of pi over 8 is equal to adjacent over hypotenuse, so 42.5. Multiply both sides by 42.5. And that should give me my y value. So we could do it that way. Nothing wrong with it. And I'm actually just going to recall that last line and go back and edit the trig ratio. Hit enter. It should give me that 39.26 number. Okay, and it does. That's not the only way we could have done it. Now there's going to be a degree of error here when I do it this way, and I think this might be why they gave these answers here. We found the opposite side here to be 16.26404, right? Could I use tangent of pi over 8 to be equal to the opposite side divided by the adjacent side? So now you have 16.26404 over y. And then multiply both sides by y. And I'll put y over here, right? And then I want to isolate y, so I'll divide both sides by tangent of pi over 8. So that should give me the same value. Now, understand it's not going to give me the exact value because there was rounding error here, right? And that rounding error is then compounded when I divide it by tangent of pi over 8. When we do that other calculation. Okay, so I'm going to take the 16.26404 number and divide it by tangent of pi over 8. And it gives you the same 39.26. Okay, but now if you look at this, we go out to the fourth decimal, they're the same, but that fifth decimal, they're different. So that fifth decimal is where that rounding error took place. Does that kind of make sense? So you can do that, just make sure you pay attention to the directions and say, You know, if it's rounded 2 decimal places, when you're using those intermediate values, round those further so that the rounding error doesn't impact things. All right, so we have found, oh, don't want to do it that way. Let me just clear all this real quick. We did what? 42.5 sine of pi over 8, right? That was that number, okay? Now, if I'm going to use that number to find other segments, obviously there's rounding issues, right? Well, if we hit the STO button, okay, and then hit X, or any letter you want to, it's now going to store that entire number as X. So when I do tangent of pi over 8, when I divide that number by tangent of pi over 8, I can hit X divided by tangent of pi divided by 8. And now, the only rounding error that occurs, and just kind of show you, when we put the cosine version in there, cosine of pi over 8, you see that that number there and that number there are now identical, right? So there's no rounding error incorporated in that. What I do need you guys to understand, though, is that 3, that is you are not confident in that 3, okay? Because that 3 could be a 3, and the number after it is less than 5, right? Okay, so it just rounding kept it as a 3. But that number could actually be a 2, but the number after it was 5 or higher, and the calculator rounds to a 3. Does that make sense? So there could be rounding error out to that last value. So we're confident up into that 1, but those things are accurate. Does that make sense? Okay. So you've got some options there if you're a person that wants to use that approach. Another approach for this question is, once you know this number and you know that number, could I say y, I go y squared plus 16.26404 squared is equal to 42.5 squared? Pythagorean theorem work there? I'm not going to go through the work with you, but it does. All right, there's nothing wrong with using that. Now the last one says find the missing angle here. What should all 3 angles in a triangle add up to? 180. Okay, so they should add up to 180, but we're in radians, so they should add up to pi, right? That's the same thing. Now, here's the thing. In a right triangle, and this is what we learned back in geometry, if you have a right triangle, what should the acute angles be to one another? What should they add up to? They should have to 90, right? They should be complementary. We had it's actually a corollary back to geometry. It said in a right triangle, the acute angles are complementary. So 90 degrees is the same thing as pi over 2. Does that make sense? Okay. So if I know that I have this angle here of pi over 8 and this missing angle, and they need to add to pi over 2, how do I find this missing angle knowing pi over 8? Yeah, take pi over 2, subtract pi over 8, right? Now, this is the issue when we're dealing with radians, is that we're always going to have common denominators. So 4 pi over 8 minus pi over 8 gives me then 3 pi over 8. And that's the acute angle then that we're looking for. Does that help? Always looking when we say solve, and now they walk you through this on the exam. They sent that out the other day. Questions like this will not prompt you to find each of these 3 things. They'll just say solve the right triangle, and in that set of directions, they think should be insightful enough for you to say, well, I got to figure out all the missing parts. And with 2 parts of any right triangle, you have the ability, or should have the ability, to find all remaining parts. Doing question number 25 here, if we want to find x, now it's a little bit of a more complicated question, maybe because of the adjacent triangles here, the attached triangles. But I think this is something we can all kind of work through. We want to find x. So in regards to finding x, I need to first Well, let's look at it this way. How many right triangles do you really have there? You have 3 right triangles. You got the smaller 2, right? Because that's a right triangle. But if that's 60 degrees and that's 30 degrees, if I collectively look at the whole triangle, that's a right triangle. Do you guys remember, and I'm not going to use this approach, you guys remember this word? Geometric means from geometry, okay, where we took, maybe one concept is that that altitude is the geometric mean between that and that, okay. And there's some other things here. Maybe when we get done with this problem, I don't know, based off the information that we currently have right now, because we have to do a little bit of work first to be able to actually use geometric means. But this is a geometric mean picture that we saw in geometry. But I think maybe to, like I said, approach it using geometric means, I need to at least have maybe that value there, or maybe at least have that value over here, okay? If I look at just this triangle on the left, it might be a good idea to redraw things every once in a while. Would you guys agree that this is my n radical 3 side for a special right triangle? And across from 30 should be my n side. So can I divide both sides here by radical 3 to solve for n? So n is going to be 150. I'm just going to write it as 150 over radical 3. The question asks it to round things, so leaving this as a unrationalized radical is fine right now. If you want to write it as 150 radical 3 over 3, that's fine. There's nothing wrong with that. Is that doable? Okay. And maybe we do that because 150 and 3 do work out real nice. Let's go 150 radical 3 over 3. What's 150 divided by 3? 50. So maybe I do write that as 50 radical 3. Maybe it serves a purpose later to rationalize that. Now, I don't need this side here. I don't need the 2n because that's not, it's that hypotenuse right there, and it's not for this question or appropriate maybe for this question, but we could if we wanted to, because if I've got n, 2n, it's just 100 radical 3, isn't it? Okay, so we've got those components right now for that triangle. You're still writing? I don't want to erase that if you're still writing it. The next thing is, so that's not all of x, right? That's only a portion of x. So now we've got to find this distance here. So doing that, I'm going to focus on that bigger triangle. If that's 30 degrees, 90 degrees, 60 degrees, this side here is going to be n. This would be n root 3, and this is 2n. Okay. Now they're telling me n is 150, right? If I take that value right there and translate it into that picture, okay, n is 150. So this distance here is 150 root 3, correct? So that distance, 150 root 3. Okay, and this side here, now we don't need it, but wouldn't 2n be 300? So this thing would be 300. Okay. Now I'm finding those additional values there on purpose just to prove a point here in a moment, because if you were uncertain about your answer here, because your answer is going to be what, 200 root 3 when I add those together, and then obviously your calculator, they want it to the tens place, so 200 root 3 gives me that number right there, rounded to the 0.4. But let's just look at some stuff here, because this overall triangle, if we were to redraw it, we just found this to be 200 root 3. This was 300. And what was, that was 100 root 3. Here's my right angle, here is my 60-degree angle, and here is my 30-degree angle. If this, for that triangle, that's n, right? Okay. Would you agree that that is 2n? Does that make sense, everybody? Would you agree that this side here is my n radical 3? If I take that number right there and multiply it by radical 3, I get 100 times 3, don't I? Which is my 300. So just in regards to checking things, maybe that's an appropriate technique, okay, to find all parts of the triangle, even though that the question doesn't address those and need those. It is an approach that you could use. Let me clean something up here. We talked, like I said earlier, we talked geometric means in geometry. And in regards to altitudes, basically. It says an altitude, which is that 150, is the geometric mean. So it goes there and it goes there. That's the locations of geometric means. Between the parts of the hypotenuse, so 50 radical 3 and 150 radical 3. So if I was curious on whether those values of 50 radical 3 and 150 radical 3 were correct, I could see if this is a true proportion. Okay, so figuring out whether that's a true proportion, I'm going to multiply, cross multiply, so I get 150 squared, gives me that number, right? Then you want to take 50. Does it make it? Can I do it this way? Because I don't want to type all this in. Can I go 50 times 150 times, what's root 3 times root 3? 3, right? Give me the same number. Okay, so that geometric mean concept tells me that those are correct. Another way of doing geometric means was dealing with the other altitude. So that is another altitude of our right triangle, because it's a side that goes from a vertex perpendicular to the other side. So 100 root 3 should be a geometric mean. Now this is between the entire hypotenuse. So the entire hypotenuse is at 200 radical 3 number. And then the part of the hypotenuse that's touching the 10 radical 3, which is 50 radical 3. Okay. Now, if we took our time to multiply that out, we got, 50 times 200, right? 50 times 200, and then times 3. Does that equal basically 100 squared times 3? Okay, and if you multiply those two things out, you're going to get the exact same value, which is what? 30,000. Okay. On both sides, 3,000 equals 30,000. And it's validation that that is correct information. Does that make sense? If you had the wrong values there, those geometric means would not equate to enough. Okay? Now, I'm not saying that I'm going to force you to learn and use geometric means right now. I think it's something now as juniors and seniors you wouldn't have a problem with. Maybe as freshmen and sophomores it was a complex procedure. But it's trigonometry, and it's a benefit. It's not trigonometry that we talk about in this course, kind of a prerequisite, but it is still part of trig and something that we can maybe adapt to our needs if we need to. The last one, 26. All right, this one here is similar in the approach, but if we look at that triangle or set of triangles, one of them is a nice one. All right, one of them is a 30, 60, 90, right? If I look at this one right here, this side here is my n radical 3 side, right? So I'm going to take that little equation, n root 3 is equal to 75. Divide by root 3, it's 75 over root 3. Rationalize that thing. I get 75 root 3 over 3, which just becomes 25 root 3, right? Is that okay with everyone? And that's, we just solved for n. And my hopes are is that eventually that, you see the pattern so often that when I'm rationalizing, basically that denominator goes in the numerator, and then you're left with a radicand on the bottom, right? Okay. So we get 25 root 3. This here, this side, would be my 2n side, right? The hypotenuse of any special right triangle is 2n. Well, if this is n, then double that, and you get 50 root 3. Everybody all right with that so far? Now, they do ask you around in decimal places, but I like to, if I can leave answers as exact values, I want to. And you're going to want to as you progress through this course. So whenever you see a 30, 60, 90 triangle, deal with the special right triangle. Don't grab your calculator and start using rounded values and that kind of stuff until the last available operation that you can. Okay, does that make sense? So, I have options. I could have started with some rounded values right away, but I know that I'm going to do further calculations. So if I would have rounded that 25 root 3 and then doubled it, that rounding is compounded by that doubling process, right? And now I'm going to use that doubled, rounded error value of 50 radical 3, whatever that comes out to be as I rounded it. And then I'm going to put it in another calculation. So that compounded error gets compounded even further. So always trying to think about, when is the last feasible situation for me to round that logically makes sense and makes things, I don't want to make things overly difficult, but I do want to have the kind of the best answer I could possibly get here. So now if I look at this triangle on the right, it's not a special right triangle anymore, right? So if it's not a special right triangle, to find side lengths, you have to use SOHCAHTOA. Okay? So if I want to find x, that's the hypotenuse, right? What side is 50 radical 3 for this 65 degrees? Opposite. So what trig ratio would you use? Sine. So sine of 65 degrees is equal to opposite, which is 50 root 3 over the hypotenuse. Okay? Now, what is the other angle up top in that triangle? Say again? 25. Okay? Could I have used that 25-degree angle if I wanted to? Yeah. And then if I would have used the 25-degree angle, 25 right here, then I would have used the adjacent side in the hypotenuse of 25, right? So the adjacent side is cosine of 25 is equal to the adjacent side, which is 50 root 3 over the hypotenuse of x. Okay? So either one of those is fine. Okay? What is 25 and 60? What do they add up to? Oh, sorry, 25 and 65. 25 and 65. What do they add to? 90. What kind of angles are two angles that add to 90 degrees by definition? Complementary. Okay? Sine and cosine have the same root word sine in them, don't they? Does one have the prefix co? What do you think that co stands for? Complementary. Okay? You see how we went sine of 65 is equal to 50 root 3 over x. And then we found the complement of that and said cosine of 25 is equal to the same thing. Okay? So we could go through here and evaluate this either way. Obviously, what happens, if you remember from geometry, we'll go through a little bit of algebra. Don't those two things just switch spots? Okay? So if I wanted the exact answer, we would have x to equal 50 root 3 over sine of 65, or x is equal to 50 root 3 over cosine of 25. Okay, those will evaluate to be the same thing. But if I'm using this to measure, I don't know, some type of structure that I'm building or something like that, I would not go to Lowe's and say, hey, I need 50 radical 3 over sine 65 feet worth of whatever, right? Does that make sense? So these are the exact values because there's been absolutely no rounding taking place. But to get the 95.6 that they're looking for here, I'm going to type one of those in, 50 root 3 divided by sine of 65. Now just remember, that 65, is that in radians or degrees? It's degrees, right? So I'm going to go change my mode. Hit enter. There's that 95.6 number I'm looking for. And like I said, if I change it to the complement, cosine of 25, should give the same number. Okay. And that's, we've talked about how like the sine and the cosecant are reciprocal relationships, right? the sine and the cosine are complementary relationships, okay? And we actually call them co-functions because of that prefix co on one of them. But you see the same thing with tangent and cotangent, don't you? You see the same thing with secant and cosecant, don't you? All right, so maybe that's kind of an introduction to that relationship that we'll see here pretty soon, within the next couple days, for co-functions.